In this video, we want to look at, again, finding all 6 trigonometric function values, but maybe we don't have the same kind of setup that we had before. For example, this one says that the terminal side of theta is defined by the equation 3x plus 2y equals 0, and x is greater than or equal to 0. So what you could do is that you could pick a value for x that's greater than 0 and plug it in and find the corresponding y coordinate, and that would be a point that would be on that ray. But something else you could do that might make a little bit more sense is to solve this for y to get an idea about what this looks like in terms of slope. So if I solve this for y, I would move the 3x to the other side, and I would divide both sides by 2. Now, I'm not saying you have to do this, but this to me, I think, makes sense. This is how I like to work it out. So if you remember how to graph using slopes and y-intercepts, the y-intercept is 0, 0 for this guy because there's nothing out there. And using the coefficient of -3/2, we can get another point that's on the line. Now, x is supposed to be greater than or equal to 0, so we know we're on the right side of the y-axis. So if I use that -3/2 and go down 1, 2, 3, and then over 2, I would have a point right here. So that means that the angle that I'm looking at is going to look like this guy. This point that I'm going through is 2, -3. And so now I want to do the whole thing about dropping the perpendicular. And let's label the diagram. So we have 2 for the x, -3 for the y. But now we need to find what is the r value. So I'm just slide this up right here. So my r, again, using the Pythagorean theorem, is going to be 2 squared plus -3 squared. All right, so that's 4 and 9, which gives me 13. Or square root of 13. That's not a really pretty number, but it doesn't matter. Square root of 13 is just a number. Okay, don't get too worked up about it. So there's our theta. Now that we have the diagram here, it's just like the problems we did in the last video. Sine is opposite over hypotenuse, square root of 13. Ugh, gotta rationalize this guy. But again, the more of these you do, the easier it is to see what's going to happen. So we have -3 square roots of 13 over 13. And we're going to do the same thing with cosine. Cosine is going to be adjacent, so that's 2. And again, remember, think about cosine as being more in the x direction, sine as being in the y direction. At least that's how it works in my mind. And so I use that in combination with the whole SOHCAHTOA thing to make sure that I'm in the right spot, that I'm picking the right values. So adjacent over hypotenuse. Remember, the hypotenuse is always going to be positive here. Rationalize. And finish. So 2 square roots of 13 over 13. And now tangent. Tangent is opposite, -3 over adjacent 2. Once you have these first 3 done, the next 3 fall out very, very easily. So I do cosecant because that is the reciprocal of sine. And again, I don't want to use the rationalized version unless I need to. So if we back it up a little bit and we look right here, flip that guy over. That gives us negative square root of 13 over 3. And I don't need to rationalize that. The secant is going to be the reciprocal of cosine. So again, here's cosine before I rationalized. If I do the reciprocal, we have the square root of 13 over 2. We don't need to rationalize. Finally, cotangent is the reciprocal of tangent. Flip this guy over, there weren't any radicals to begin with, and we've got -2/3. And we're done. So drawing a picture, getting an idea about where this part of the line goes, finding a nice point with integer coordinates, draw the triangle, and then we answer the questions. All right, let's see. What is next? So we want to find all 6 trigonometric function values if your theta is equal to 270 degrees. So for this one, draw a picture. Now, what's going to be different here is that I'm not telling you a point that you go through. I'm giving you the angle measure. So 270 degrees is going to be all the way around here. So it's going to be having a terminal side that's along the y-axis like that. These guys can be kind of difficult, or they can be kind of easy. If you just pick a point right here. Now you might say, how can I just pick a point? Well, you're on the y-axis and you're below the x-axis. So you know the x-coordinate is going to be 0, and you can just pick whatever y value you want as long as it's below. So let's say -2, right? That would be on the terminal side of an angle whose measure is 270 degrees. So remember, you've got 0, 90, 180, and then 270 degrees is going to be facing south. All right. This might be kind of tough because we don't actually have a triangle, right? Let's see what happens. If I do sine, and let's go back and look at the definitions, how we have the ratios defined with x, y, and r. So sine is supposed to be y over r. My y value is -2. My r is going to be the distance from the origin to that ending point, and so that's a value of 2. So sine is -2 over 2, and that ratio gives me -1. Okay? Cosine of theta is x over r. Now my x value is 0, my r is still 2, so my cosine value is 0. Okay. I mean, it just kind of is what it is. And also when you think about it, like what is your x value if you're on a y-axis? Your x value is 0, right? So it doesn't matter how big or small that radius is, how big or small that hypotenuse is, 0 over anything is going to give you 0. Things are going to get a little bit weird though. Tangent is y over x. My y value is -2. My x value is 0. So that means that this guy is going to be, he's going to be undefined. So when we defined these guys before, we said, sine and cosine, we shouldn't have any issues because r is always going to be something positive. But for tangent and the rest of these guys, you had to make sure that your denominator wouldn't become 0. And it is, so we're having an issue. All right, so let's look at doing those reciprocal functions. So cosecant is supposed to be r over y, which is 2 over -2. It's still -1. Okay. Secant is the reciprocal of cosine. So r over x, which is 2 over 0, which is going to make us undefined. Remember, you can't divide by 0. So when 0 is under the line, the expression is undefined. And then finally for the cotangent. Cotangent is the reciprocal of tangent, but you can't really do reciprocal of undefined. That doesn't really make a lot of sense. But it is defined as the ratio of x to y, which is 0 over -2, and that's equal to 0. All right, so if you don't have a good triangle, if you're dealing with something that is a quadrantal angle, draw the picture, identify your x and y. Your r is just going to be the distance that we have from that origin to that point. Let's look at the next example, and you're going to see something very similar to that. In the next example, we are going through the ordered pair 5, 0. So here's 5, 0. We clearly see what our x and y values are. Your r is going to be this guy right here. So r is going to be 5. Let's do the same ratios that we had before. So sine is y over r, which is 0 over 5, and now sine is equal to 0. And think about that. How much is this point above or below the x-axis? It's not. It's not above it. It's not below it. So sine is going to give you 0 because sine is connected to that y value. Cosine is x over r, so that's 5 divided by 5, and we get 1. Okay. It's about as big as cosine can be, actually. Tangent is supposed to be y over x. So 0 over 5. It's 0. It's not undefined. Well, that's nice. Now for those reciprocal ones. Cosecant of theta is r over y. Basically, you're trying to do the reciprocal of 0. So if I have 5 over 0, then this expression is going to be undefined. Secant is supposed to be r over x. And so if you turn 1 upside down, you still just get 1. And then finally for cotangent, x over y is 5 over 0, which again will be an undefined expression. All right, so now that we've gone through all of this, hopefully you can now jump into my math lab and take care of the homework exercises related to these trigonometric functions. Draw your picture, pay attention to your signs, okay? And when we come back, get to a new chapter or a new section and even more fun math.